A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, instructor for the NPTEL MOOC course, Pavement Construction and Technology, funded by Ministry of Education, Government of India. Now today's lecture will be under module 6 and it will be the continuation of our talk where we discussed about the construction aspects related to different granular courses. We discussed the construction aspects of granular sub-base course, then we discussed the construction aspects of waterborne macadam course. So, we will continue our discussion with granular base courses in today's lecture. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. So, the other very popular granular course is of wet mix macadam, which is preferably used as a base course in the construction of road pavements. Now, it is quite popular because it gives a quite durable granular base course in pavements, and when you compare with waterborne macadam, the preference is given more to wet mix macadam, especially when to be used as a granular base course or in some cases as a granular sub base course. And the reason behind this particular one is the wet mix macadam offers advantages including superior aggregate gradation. The gradation is superior in terms of the density which is it is going to provide. Faster construction rates are there with this kind of material, as you have seen in case of waterborne macadam. The coarse aggregates have to be laid first, compacted, then thereafter the screenings have to be applied, along with the sprinkling of water it has to be compacted, then thereafter the binding material has to be applied. So, and a lot of care has to be taken during those process. So, that delays or we can say reduces the construction quantity specifically. So, the construction rates are much higher specifically in wet mix macadam when compared to waterborne macadam. Higher standards of compaction, the requirement is higher specifically. Reduced water consumption, as we have seen there, the application of water is there during the application of screenings also and during the application of your binding material also, and the quality control, because here the production, most of the times the production of this mix is done through a wet mix plant. So, a better control is there, and then it is laid in the field with the help of a paver also. So, in both the cases you get better quality control with these wet mix macadam when compared to waterborne macadam. So, the key steps involved in the construction of a wet mix macadam is preparation of the base, as we did the preparation of base even in case of granular sub-base courses also, even in the case of waterborne macadam also. So, every time whatever the layer has to come up, the existing layer has to be made ready in terms of the upcoming layer which is to be constructed. Lateral confinement of aggregates, specifically the material has to be there. Preparation of the mix, which is in this particular case most commonly done through a wet mix plant. Spreading of the mix, so it can be done with a motor grader or with the help of a paver. Compaction that has to be carried out, and the setting you have to look into it if any undulations or depressions are there. So, that needs to be done, checked, ensured, and then it has to be left for 24 hours before finally opening for the traffic. So, in addition to our MORTH guidelines which is there with us, which gives the information about the wet mix macadam, we have IRC 109/2015 also, which is guidelines for wet mix macadam. Along with that, we have IRC 126/2017, which is guidelines on wet mix plant. So, these are additional guidelines available from Indian Roads Congress. Now, coming to the construction operations, one climatic related challenges or the seasonal related challenges that this construction should not be carried out when there is some rainfall event is there. So, we will avoid when this kind of event is there, because this will disturb the foundation also, and this will disturb the construction also in terms of the composition because of the increase in the water content. So, during rainfall event, the laying of wet mix macadam is avoided. Now, as the preparation of sub-base or the preparation of the underlying course is important, whenever you do for a new construction, you need to ensure that the existing should be to the specified lines and camber, because that will help us to maintain the camber and the levels for the layer of wet mix macadam also, and thoroughly cleaned of dust and other extraneous materials are there, then it needs to be cleaned. And since most of the time you will have granular sub base courses over which you follow with the construction of a granular base course. So if you find because of any movement of the construction vehicles may move over that particular one, it is always avoided and to allow the movement of the construction vehicles over these layers which are getting constructed. So any ruts, but if unfortunately this happens, any moving traffic gets shifted over it, because of which any ruts or soft spots are created, they need to be rectified and compacted. That can be done specifically by opening up the surface, sprinkling the water, and again doing the compaction so as to get a firm surface. Laying WMM over an existing bituminous surface is usually not permitted. Same was the case when we discussed about the waterborne macadam also. Lateral confinement of wet mix layer. Whenever these layers are to be laid, as you can see on this particular side, if we are laying it, and if this side is at a lower layer compared to what is the level of your wet mix macadam, then while compacting at the edges, the mix will slide down. This will lead to a reduced thickness also, as well as a lower density at the edges. So for that particular reason, we need to confine those edges, and the easiest way of doing that particular one is by simultaneously constructing the material which is to be there in the subgrade. So it says during the construction of wet mix macadam, appropriate arrangements are taken to ensure lateral confinement of the wet mix, mainly achieved by the simultaneously laying the material for the adjoining shoulders. So when we do this particular exercise, especially for wet mix macadam, in case of granular subbase courses or drainage courses, they are extended to the open edges. But when it comes to your granular base courses, you start with the construction of your the shoulders by putting up some specified material. Mainly for shoulders, earthen shoulders, we go for subgrade soil. The soil which meets the requirement of the subgrade construction, preferably that is used for your earthen shoulder construction purpose also. So we'll go for the simultaneously laying the material for adjoining shoulders along with the WMM layer. It says it is to be ensured that the construction of the shoulder is carried out in layers, and that too it should not happen. There may be two layers of WMM, each may be say of 100 mm thickness or 150 mm thickness, so 300 mm of total WMM thickness. So it should not happen the entire 300 mm of thickness of subgrade which is adjacent to WMM is constructed in one go. You should prefer to go for the construction which is in line with the layer which you are constructing. So if the WMM layer is of 200 mm thickness, you will prefer to go for the subgrade with a thickness of 200 mm. So is carried out in layers, each corresponding in thickness to the adjoining pavement layer. So that will give you the confinement which is required for the compacting that particular layer. The next layer of the pavement and shoulder shall only be taken up after the previous laid layer of both has been properly placed and compacted. This is always there. The permission we put up in actual construction practices, we normally put up a request for inspection. So an abbreviated form is RFI. So we put up a request for inspection that we have constructed a layer. Now the agency can come and inspect it, and if that is found okay, the permission is given for the construction of the next layer. So once the existing layer has been ensured for the whatever the parameters in terms of the density, in terms of strength, gradation, levels, it is to be checked, it needs to be ensured. Thereafter, it gets the permission for the construction of the next layer over it. Now, the production of this particular mix, wet mix macadam, is preferably made in a wet mix plant. So now here, because we need a good control in terms of the aggregate proportioning, we need a good control in terms of the water content which is to be there, we need to avoid any segregation, we need to have a uniform mixing that is to be there, we want to have a high production rate, and even along with that particular one, we prefer to bring down the cost per unit of production also. So for those purposes, mainly the wet mix macadam is produced with the help of a wet mix plant. Now it says it is, and we have codal guidelines which gives you the information about the wet mix plant. This wet mix plant can also be used specifically for production of granular sub-base courses also, and even the one can be produced for used for the production of cold bituminous mixes also, and sometimes also used for the production of soil stabilized courses also. So it can be put to multiple uses, but for wet mix macadam, which is used mainly as a base course, we prefer to use a wet mix plant. Now the wet mix plant must have a system to have a controlled addition of water, and should have a forced mixing method similar to like a pug mill is there. So we will show how a pug mill looks like, or a pan type mixture which normally we have for concrete batching plant. So this is, so a forced mixing is there so as to achieve a uniform mixing and to avoid any sort of segregation which is there. So the WMM plant should have features for feeding the aggregates. Now this is, I will show you on the next slide also. You can see here the features are, there will be these cold feed bins, the bins are there. I will show a more detailed one in the next slide. So what are the arrangements which are required, because there may be 3-4 different sizes of aggregates which you may be proportioning for use in wet mix macadam. So you need bins where these different sizes can be stored, and from these different sizes of the bins, it has to be taken up in the required proportion, and then we have normally a screening deck to separate out the oversized aggregates, and then taken to a pug mill mixer where the right quantity of water is added, mixed, and then it is taken out. So we need to have proper arrangement for feeding aggregates. A conveyor belt is there to take the aggregates from these bins to your pug mill mixer. In between we have a vibrating screen also, so as to unfortunately some oversized aggregates may have come into the stockpiles, so that need to be separated out, and all this is done through a control panel. So you control all these functions sitting near the plant, and where you can control the speeds of your conveyor belts, where you can look into the opening of the gates of your these bins. So all these exercises are done, and normally a wet mix plant of a capacity around 100 ton per hour to 300 ton per hour is used for these producing the wet mix macadam. This plant should work in a manner which can give you a controlled mixing in terms of the moisture content. So optimum moisture content shall be determined, which is already determined in the laboratory as per our IS 2720 part 8, where we determined the relationship between the moisture content and the density. So that is to be added during the production of the wet mix macadam mix in this pug mill, and we need to take care of any allowance which is required for the environmental losses which can happen during this production process. So you can see here is the dry aggregate which is moving through the conveyor belt, then here we are in the pug mill mixing with the water, and finally it is coming out, and the tipper is going to carry the prepared mix to the site. So this is a clear picture of a wet mix plant where the different components are shown here. You can see there, these are the bins, 1, 2, 3, 4 bins are there. Then there will be auxiliary conveyor, so which will be there for each individual bins, and the gates, there will be an opening to these bins will be there. So aggregates will come out depending upon the required proportion which you have achieved during your design. So the gates will be opened, the auxiliary conveyor will put up your material over the feeder conveyor which is there, or the gathering conveyor which is there. There is a bottom, a gathering conveyor will be there which will collect material from all these bins. Then we have a vibrating screen here. So, this vibrating screen, we drop the material over the vibrating screen. It is a single deck vibrating screen is there, so as to separate out the oversized material. Then once that is done, it moves through the Slinger conveyor to your this pug mill unit, and where the required quantities of water is added to it, and then it is mixed in the pug mill, and then it is taken out. It is the load out conveyor is there, and the tipper will come here and the mix will be poured into it. If the rate of production is high compared to what the availability of tippers is there, it can be stored into your storage silos. And this is a control cabin through which all these activities will be controlled. So, a WMM plant has provisions for control feeding of aggregates of different sizes in the required proportion. So, this is important. Whatever proportion you have finalized to achieve the target gradation can be well controlled in this wet mix plant. We will discuss these plants again when we will be discussing the bituminous mixes, because there the mixes are produced commonly by using highly advanced these plants, when we call them as hot mix plant also. So, bituminous plants, there again some of the features remains common. So, we will discuss about those features again during the discussion about the bituminous mix plants. Some of the features will be again discussed there. So, addition of a specified quantity of water. In addition to the water, if we are looking for some stabilizing additives also, many a time cement may be used or lime may be used, then that control addition can be done specifically to the pug mill along with the addition. So, we will have a dedicated bins which will be there for, we can call for the filler material, which may be your cement or hydrated lime or any other stabilizing additive. So, addition of a specified quantity of any other ingredient or additives like lime or cement is also possible. Forced positive mixing of all the ingredients to produce a consistent mix. So, this is important. What we get, there is a uniform mixing of water which is there, uniform mixing of any additive which is incorporated, and the produced mix does not have any segregation. So, this is a benefit when we do it with a wet mix plant. Now, further some of the components are shown here and explained. As I mentioned that and this is depending upon how many different aggregate sizes you are proportioning. There may be, depending on that, there may be 3 bins or there may be 4 bins. Typically, it ranges from 3 to 5 bins at a. So, we have these individually bins. So, from dosers, the materials will be shifted to these bins, and then as I mentioned, there will be individual. We will discuss more about these cold bins in bituminous plants also. So, there will be auxiliary conveyor under each of one of it. So, that gate will be opened for this one, it will fall over the gathering conveyor. This gathering conveyor will collect material from this bin also, from the auxiliary conveyor of this bin also, from the auxiliary conveyor. So, individual conveyor is also there, and the one which is bottom is gathering conveyor, which collects the materials from all these conveyors. So, a gathering conveyor collects aggregates of different sizes from the auxiliary conveyors fitted under each bin and discharges it into the slinger conveyor. But before getting discharged into the slinger conveyor, there is an oversized removal screen is also there. So, once the gathering conveyor is there, it collects material, and the way the speed of the auxiliary conveyor, the individual gate opening of each of the bins is to be controlled in a manner to get your desired proportion of each sizes. So, if you have A, B, say 3 aggregates to be used in proportion of 40, say 50 and 10%. So, this has to be controlled through the opening of this particular one and the auxiliary conveyor speed. So, as to achieve a proportion of this 40, 50 and 10. Once the gathering conveyor is there, if there is by mistake some chances are there that some bigger materials have entered into the stockpiles, so that oversized materials can be removed through this particular screen. So, the gathering screen drops a material on this oversized removal screen, and what is it? It is a single deck vibratory screen is there with adequate screening area, bigger screening area, and appropriate vibrating mechanism is there. So, it is a single deck one. There is, so the top oversized materials will be separated out, and the bottom size material which are accepted for this particular wet mix macadam mix will then move with the help of the cylinder conveyor to your pug mill mixer. So, a single size deck vibrating screen with adequate screening area and appropriate vibrating mechanism is installed at the discharge end of the gathering conveyor. So, once the gathering conveyor which collects the material from these bins will discharge the material to this particular oversized removal screen to reject any oversized aggregates before they can be fed on the cylinder conveyor. So, once this conveyor is there, it separates out the oversized material, and then the cylinder conveyor comes into picture, which takes your material to your pug mill. So, a pug mill typically consists of what is there. You can see this is an example of a pug mill. So, it is a twin shaft system. Typically, we have a twin shaft system with each shaft equipped with high abrasion resistance. These are pedal arms. These are pedal arms which are there, and the number of pedal arms or the tips also depends upon how much is the capacity of that particular plant. And these pedal arms or the in this particular pug mill mixture helps to facilitate effective forced action mixing of aggregates and binder. So, this aggregate and binder here is water. So, the and any other additive which is to be added. If there is no additive, then it will be aggregate and water only. So, once that this mixed one comes from the pug mill, you will have a good gradation along with a proper mixing of water, which, so this finally this is what is aimed once it comes out through your pug mill. Now, from the pug mill you will look into it if it can be directly put into the tipper, or it has to be stored for a period of time before it is finally laid and compacted in the field. Now, then it comes to the field. Once this is produced, we have done it through a wet mix plant for a better quality control or for a homogeneous mix with a uniform controlled water content. Now, then that particular mix is brought to the field. Now, there again it is preferred that we go for the laying of this wet mix macadam with the help of a mechanized paver. The different components of pavers we will discuss when we will discuss bituminous mixes, because construction of bituminous mixes, because pavers are widely used in the construction of bituminous mixes. So, here I will just give you an example. So, whatever mix which has been produced from your wet mix plant comes here, is dropped into this hopper, and then it comes out on this particular end, and you get a uniform thickness of the loose mix. Now, this through your trial stretches you will work it out what should be the loose thickness, so as to get your final targeted compacted thickness. So, that needs to be done through trial stretches, where you will decide the way the compaction has to be carried out with the available compaction equipments or rollers which you have. So, and this will depend upon the material composition, your compactive effort, the type of rollers which you have. So, from your trial stretches you will work it out how much amount of loose thickness has to come out. So, this paver will help you to provide your loose mixes to the required camber also. So, the required camber, or I will say the cross slope, it can be, this is a screed which gives you the required camber and slope. So, the loose mix will come up to the required thickness, and this takes well care of your cross slope and levels. So, the paver is a very helpful equipment to get a proper profile and a thickness of your loose mix. So, immediately after mixing, the material should be uniformly and evenly spread over the prepared subgrade. Normally, we do not go over subgrade, we go over a sub-base course or a base course, because there may be, if two layers of WMM is there, then there may be one layer WMM 1, WMM 2 in the required quantity, preferably using a paver finisher. But in many cases, small projects, you may not have a paver finisher with you. then in those particular cases you may require to use a motor grader, which we have seen when we were doing the spreading in case of granular sub-base courses. So that motor grader may be used, but otherwise for bigger projects we will always prefer to go for a paver finisher. In specialized cases where it is not possible to utilize the paver, mechanical means like a motor grader may be used, but with a prior approval. The motor grader shall be capable of spreading the material uniformly all over the surface. Then there it has to be, the uniformity of the material has to be maintained, the cross slope has to be maintained with the grader. So that needs to be ensured. You have to be more careful specifically when this is done through motor grader compared to a good quality control which you achieves with these pavers. Now, in addition to this particular one, when the mix is transported and it is spread over the surface, you need to ensure that the hauling of mix over a freshly compacted stretch is not permitted, because that may disturb or stress distress may be there the existing your course which is freshly laid. If the construction vehicle moves over it, it gets distressed. So we will avoid hauling of the mix over the freshly prepared surface. And in order to avoid moisture, and when this is produced from the plant, a wet mix plant, because you may have a wet mix plant which may be far away, say 20-30 kilometers far away from your actual construction site, because there are guidelines to establish the wet mix plant also in terms of the environmental regulations also. So if it is far away, when you bring those the wet mix to your construction site, there may be loss of moisture is there. So to avoid that loss of moisture, we may cover the mix using some tarpaulin also. So the mix, when brought through use of tippers, it can be covered so that the loss of moisture is minimum. Here you can see again the spreading is done with this particular one. This is what is done with the help of a screed, a paver finisher. We will discuss in detail in these components of paver finishers when we will discuss the bituminous mixes construction further. So once this particular part is done, thereafter the compaction starts. Now here, before this one, as I mentioned, the paver can ensure you give you the loose thickness which is to be there. So once that loose thickness is there, then the compaction process starts and the layer gets compacted. So we have to pick up the rollers accordingly, that what is the thickness which is to be compacted, so that the entire thickness gets compacted and a uniform density is achieved. So it says for a thickness up to 100 mm, a smooth wheel roller weighing between 80 to 100 kilonewton may be used, specifically for a thickness of up to 100 mm. And when the thickness is up to 200 mm, this is the maximum thickness usually constructed with a wet mix macadam. So a vibratory roller of 80 to 100 kilonewton is to be used, and this will have, as we have seen, there is a combination of your frequency, vibration frequency and amplitude which we works out. So we need to see, as we have seen earlier, that initially we can go for higher amplitudes and lower frequencies, and later on when the mix becomes stiff, we will prefer to go for lower amplitudes and higher frequencies. So this is when we are doing the compaction for thickness of 200 mm, we will prefer to use vibratory rollers. Now there again, when we are doing this compaction, we need to ensure that if there is a one side cross slope is there, especially at super elevations, we will prefer to start from the lower edges and we will go towards the upper edges. If there is if a camber is there, then we will prefer to start compacting from the edges, we will move towards the center. So this needs to be ensured. If this kind of thing is there where a camber is there, then we will prefer to start from the edges. We specifically go for compacting the edges first, to and fro passes over the edges, and then we will move towards the your center line or the camber. Now during this particular part, again when these roller passes are there, at least when the next pass should overlap at least 1/3 of the previous pass. So this is to be taken care. So this is done when you have a camber. If one cross slope is there, specifically in case of your super elevation, we start from the lower edges and we go towards the upper edges. So or we call them as inner edges and outer edges also. And preferably we go for compaction at a roller speeds which are around having a maximum speed about 5 km/h. Now in addition to this particular one, it is important to ensure that the moisture contents remains in the range of ±2% of OMC. See, this is a dense material where, and if additives are there, then it is very important that the amount of water content is to be well as close as to your OMC as possible, so as to achieve the required density. Because when you will prepare the trial stretches also, you will be preparing it in a given range of your optimum moisture content. So that compactive effort will be able to achieve density only if the moisture content is that prescribed range. So it is very important while transporting the mix also, and it should not be left open. Immediately once the wet mix macadam mix is laid in the field, immediately we should start with the compaction process of it. Rolling shall be continued till the density achieved is at least 98% of the maximum dry density. So this is again an important requirement, that when we, so simultaneously in the next lecture we will discuss about the checks or the field control test which are done to ensure the density, to ensure the levels of this particular one. During the compaction itself, continuously we got an idea from trial stretches also, but again we can do some monitoring specifically to ensure that the compaction has given us a density which is more than 98% of your maximum dry density. Now once this particular part is done, it is always advisable that the wet mix macadam course which is constructed shall be allowed to dry for 24 hours before the next course is constructed. So this is again important, that once you have constructed a wet mix macadam surface, this is how a compacted surface looks like. It should be allowed for at least 24 hours to dry up before we go for the construction of the next layer. So this is all about the construction aspects of the wet mix macadam. Thank you so much.